The point here is that which value of x is acceptable. Okay, whether I should take x is equal to plus 1 by root 2 or whether I should take x is equal to minus 1 by. That for that, to check that which value is acceptable, I will use this condition here. 1 minus xy is greater than 0, this condition. Now if you see, this entire part here is x and this entire part here is y. So whatever values of x that you have got, x is equal to plus or minus 1 by root 2, this holds the above results holds when 1 minus, what is x here? As I told you, x here is x minus 1 into x plus 2. So 1 minus x minus 1 by x minus 2. And what is y here? As I told you, y here is this part, x plus 1 by x plus 2. Right, x plus 1 by x plus 2. The above result holds if this is positive, right? 1 minus xy is positive. So now we shall solve this equality and see what is the acceptable range of values. Okay. So what you do here is you can write this as 1 minus x minus 1 into x plus 1 divided by x minus 2 into x plus 2. Good morning. Greater than 0. Now this becomes 1 minus x square minus 1 by x square minus 4. Applying a plus b into a minus b formula, right? This is greater than 0. Now you take the LCM on the left hand side. LCM is x square minus 4. So you get x square minus 4 minus x square minus 1 is greater than 0. That means now you open the brackets in the numerator on the left hand side, x square minus 4 minus x square plus 1 divided by x square minus 4 is greater than 0. Now clearly in the numerator, x square and x square, they cancel each other. So you simply get minus 3 by x square minus 4 is greater than 0. Now how to solve this inequality? See, if you see in the numerator, you have a negative number, right? Minus 3. Okay, and this fraction here is positive, greater than 0. That means this denominator has to be negative. Only then the fraction will be positive. That means x square minus 4 is less than 0, has to be negative. Is this clear or not? No problem in this part? Okay. So if x square minus 4 is less than 0, that means x square is less than 4. Now, if you remember, I told you when I was doing quadratic inequalities in the last class that whenever, in class 11, in fact, that whenever we have x square less than or equal to, or even less than equal to or less than a, then always x must lie between minus root a to plus root a, isn't it? Whether the equality is there or not. That means if x square is less than 4, that means x has to lie between minus 2 and plus 2. So what are the acceptable values of x? The acceptable values of x are only those values which lie in this range. So here, what was the value of x that we got? Here x we got as plus or minus 1 by root 2. Okay, now if you rationalize the denominator to check what is the value of 1 by root 2, you multiply numerator and denominator by root 2 to get root 2 by root 2, root 2 by 2, which is equal to plus or minus 1.414 divided by 2, which is equal to plus or minus 0.707. So tell me, plus 707, does it lie between minus 2 and 2? Yes, isn't it? Minus 0.707, does it lie between minus 2 and plus 2? Yes, that also lies between minus 2 and plus 2. So clearly, plus or minus 0.707 lies between plus 2 and minus 2. Hence, both the values of x are acceptable. Both the values of x are acceptable. Hence, that is, right, that is x is equal to plus or minus 1 by root 2 is the required solution. No questions or any questions? Move on to the next problem then. This is from your IC actually, this problem. The question here is, okay, well, not an IC question. IC question I'll discuss a little later. This is a different question here. Question is, if cos inverse x by a plus cos inverse y by b is equal to theta. Prove that x square by a square minus 2xy by ab cos theta plus y square by b square is equal to sine square theta. Okay, this is the question. Start with the solution. So we start with what is given. We have cos inverse x by a plus cos inverse y by b is equal to theta. Now this is an addition of two cos inverses, right? So you know how to combine two cos inverses, cos inverse x plus cos inverse y, use that formula. So you get cos inverse. What is cos inverse x plus cos inverse y? It is cos inverse xy minus root 1 minus x square into root 1 minus y square. It was a formula, you remember, is equal to theta. That means you have cos inverse xy by ab minus root over 1 minus x square by a square into root 1 minus y square by b square is equal to theta. That means you can get xy by ab minus root 1 minus x square by e square root 1 minus y square by b square is equal to cos theta. Okay, now you take the radical, both the radicals that are there, you take it on the right hand side. Okay, so you get xy minus ab and you bring cos theta on the left hand side. Xy minus cos theta is equal to square root of, you can also write this, you can write it under a single radical, since this is a product of two radicals of the same order. You can write this as 1 minus x square by a square into 1 minus y square by b square. Now you square both sides. So remove the radical. Means you have xy by ab minus cos theta whole square is equal to square root of 1 minus x square by a square into 1 minus y square by b square whole square. Okay. So that in the next step now you can remove the radical, and not only remove the radical, but what you can also do is you can expand on the left hand side by a square a minus b whole square formula. So if you expand this by a minus b whole square formula, you get e square minus 2ab okay plus b square is equal to, and this simply becomes 1 minus x square by a square into 1 minus y square by b square. Okay, this is what you're going to get. Now what you do here is you write this as x square y square by a square b square. Okay, and this as minus 2xy by ab cos theta plus cos square theta is equal to, on the right hand side you multiply it. You get 1 minus y square by b square minus x square by a square plus x square y square by a square. Okay, so clearly what you see here is that x square y square by a square because we cancel from both sides, right? And now what you do is you transpose this quantity and this quantity to the other side. Both these quantity you transpose to the other side and you will get your required result. So what you get here is x square by a square plus y square by b square minus 2xy by ab cos theta is equal to, now cos square theta you transpose to this side, you get 1 minus cos square theta, which is sin square theta, and therefore which is the required proof. That means x square by a square minus 2xy by ab cos theta plus y square by b square is equal to 1 minus cos square is sin square, which is your required proof. Any questions on this? Move on to the next problem. Problem here is, if sin inverse x plus sin inverse y plus sin inverse z is equal to pi, prove that x square minus y square minus z square plus 2yz root 1 minus x square is equal to 0. This is what you have to prove here. So we start with what is given. So we have sin inverse x plus sin inverse y plus sin inverse z is equal to pi. Now what you do here is you take one sin inverse on the other side. Simply you cannot add two sin inverses together. Okay, you add two sin inverses. Let us say I add up sin inverse x plus sin inverse y, and because I have a pi on the other side, I take this sin inverse x on the other side, pi minus sin inverse z. Now I can add up the two sin inverses on the left hand side. You know sin inverse x plus sin inverse y is x root 1 minus y square plus y root 1 minus x is equal to pi minus sin inverse z. Okay, now this can be written as the quantity that is within the sin inverse, that can be written as sine of whatever is there on the right hand side, can be written as sine pi minus sin inverse z. And you know that sine of pi minus theta is how much? Sine pi minus theta, 0 to pi, right? Isn't it? Even multiple of pi. Sine twice into pi by 2 minus sin inverse z, right? So that means x root 1 minus y square plus y root 1 minus x square. This is an even multiple of sine. So sine will remain sine. And which quadrant is this in? This is in the second quadrant, right? Pi minus something is in the second quadrant. So this can be written as sine of sin inverse z, right? So that means now sine inverse z will simply become z. Simply becomes z. Okay, and keep an eye on what you need to prove. You've got this. Now what do I need to prove? I need to prove that x square minus y square minus z square. Okay, so what I'll do here is, in order to get x square minus y square minus z square, I will take z. I will say I will take z minus of this and square both sides. Minus of, say, y root 1 minus x square, and then I will square both sides. That is, I write this as x root 1 minus y square is equal to z minus y root 1 minus x square. Now I can square both sides. Okay, so when I square both sides, I get x square 1 minus y square is equal to a square plus b square minus 2ab. Okay, so that you get now x square minus x square y square is equal to z square plus y square into 1 minus x square minus 2y root 1 minus x square into x square minus x square y square is equal to z square plus y square minus x square y square minus 2y root 1 minus x. So now minus x square and y square, they cancel from both sides. So therefore, now if you take everything to the left hand side, this is what you're going to get. You're going to get x square minus y square minus z square plus 2. This is yz. Okay, this z is here. I've forgotten to write z here. So, plus 2yz root 1 minus x square is equal to 0. And that is the required. Okay, any questions on this problem?
No, sir.
Move on to the next problem, which is now an ISC problem. And this problem wasn't as easy either. Problem. The question here is prove that tan inverse. I hope you are writing this in your copies, all this. Because if you are not, then you are harming yourself actually. So at this level, I don't know whether the correction school will ask for corrections. But if you are not writing, you are actually harming yourself. Because these are the variations of problem that you will cover all the variations, and besides it will help you revise just before the exams also. Fine. Solution. So you need to this to prove. So you start from the left hand side. Tan inverse half tan 2a plus tan inverse cot a plus tan inverse cot cube a. Now what you do here is you see that there, I mean, it looks like as if you reached a dead end. There's tan 2a cot a, that cannot see any relation. But what you easily observe, what you can not easily, but you definitely you can observe later on that if you combine these two, tan inverse. What was the formula? Tan inverse x plus tan inverse y is equal to tan inverse x plus y by 1 minus xy. Right? This was the formula. So which is equal to, you keep the first one as it is. Tan inverse. You can write this as, in the numerator you can take cot A common. So you can only get 1 plus cot square A. And in the denominator you get 1 minus cot to the power of 4A. Okay. Which is equal to tan inverse half tan 2A plus tan inverse. Now here what we are going to do is, the denominator of this, that is 1 minus cot to the power of 4A that you can see in the denominator. Numerator we have written as it is. This we are going to split as 1 plus cot square A into 1 minus cot square. Can I write this in this way? 1 minus cot to the power of 4A. Yes, Devanjan, can I write?
Yes, sir.
So tan inverse half tan 2A. What we essentially get here is, we are simply getting cot A by 1 minus cot square. Okay. Now what we do here is, we change the cot to tan. Okay. We change this cot to tan. If you convert this cot to tan, and then you will have to take the LCM. See that if you take the LCM in the denominator, you will get a tan square A in the denominator of the denominator. So 1 by tan A you are getting in the numerator. In the denominator, you will get 1 minus tan square A by tan square. Right? So that tan A cancels here and this square cancels here. So what you are going to get here is tan inverse half tan 2A plus tan inverse of tan A by 1 minus tan square A. Now does this, tan square A minus 1. So this is not 1 minus tan square A. This is actually, if you take the LCM, you get tan square A minus 1. Isn't it? That was a mistake. Tan square A minus 1. So that now in the denominator, you get tan A by tan square A minus 1. Fine. So now, does the second term look anything from familiar to you? To me it looks, because see, if I take a minus half here, and I can write 2 tan A here in the numerator, and here I can write, because I have taken a minus sign here, 1 minus tan square A minus 1 I can write as 1 minus tan square. I can write it in this way. Now why have I written in this way? You'll just see now. Plus tan inverse. See, what is this? This is multiple angle formula, right? For tan 2A. That is why I have written in this manner. This becomes minus half tan 2. Now you can combine these two tan inverses is equal to tan inverse half tan A, half tan 2A minus, in fact, plus of minus half tan 2a divided by 1 minus half tan 2a into minus half tan 2a. So what happens? In the numerator, these two will cancel, right? You'll simply get tan inverse 0, isn't it? And what is tan inverse 0? Tan inverse 0 is 0, which is the required proof. Any questions on any step in this problem? Yes, no questions? Move on to
No,
a,
sir.
move on to a very simple problem then. The question here is solve the following equations. First one is sin inverse 2a by 1 plus a square plus sin inverse 2b by 1 plus b square is equal to 2 tan inverse x. This is the first equation. And the second equation is sin inverse 6x plus sin inverse 6 root 3x is equal to minus pi by 2. These two are the equations that you need to solve. Okay, so first one looks fairly simple. So we start with, we have sin inverse 2a by 1 plus a square plus sin inverse 2b by 1 plus b square is equal to 2 tan inverse x. Okay. Now sin inverse 2a by 1 plus, does this ring any bell? Sin inverse 2a by 1 plus a square. If you remember, I had shown you 2 tan inverse x is equal to sin inverse 2x by 1 plus x square. You remember this? Yes? Does it ring any bell? Formula?
Yes, sir.
Yes. So we'll write this directly. Okay, sin inverse 2a by 1 plus 1 plus a square can be written as 2 tan inverse a. Okay. Similarly, sin inverse 2b by 1 plus b square can be written as 2 tan inverse b is equal to 2 tan inverse. Now you can take 2 common. Okay. So that now 2 gets cancelled from both sides. Now you combine on the left hand side, you combine the 2 tan inverses. The formula for tan inverse x plus tan inverse y is tan inverse x plus y by 1 minus xy is equal to tan inverse x. Now that means x must be equal to a plus b by 1 minus b. That's it. No question. So it's a fairly simple problem, right? Let us do the second one then. Question here is, we have sin inverse 6x plus sin inverse 6 root 3 x is equal to minus pi by 2. Okay. Now see, the whenever you get this kind of a problem, okay, sin inverse, solve this equation, sin inverse this plus sin inverse this is equal to minus pi by 2. Always try to take one sin inverse on the other side. That will make your task easier. Otherwise, what you're going to have is, suppose if I want to combine these two sine inverses by sine inverse x plus sine inverse y, see what is going to happen. I'm going to land up in a little bit of mess. Although I may be able to solve it ultimately, but the mess that I'm going to get in is these radicals. You see these radicals? This is the mess that I'm going to get in. That is, see, I'm getting the two radicals, and that too I've got a plus sign in between. Okay. So now I'm going to have a very tough job solving this problem because I have to square, I'll get a power of 4. That is, I'm going to get a biquadratic. And then I'm going to solve that biquadratic. And then again, once the solution that I get, I will have to check with the original equation. That is, I'm going to get 4 solutions. And all those 4 solutions, I will have to check with the original equation, which is acceptable and which is not acceptable. So whenever you see a convenient number like pi by 2 on the right hand side of such equations, you try to take one sine inverse on the other side to make your task a little bit easier. Okay, so let us take one sine inverse on the other side and attempt to solve this problem. So let us take sine inverse root 3x on the other side. You can take sine inverse 6x also on the other side. Sine inverse 6 root 3x. Okay. So now what you can do is you can write 6x as sine of minus pi by 2 minus sine inverse 6 root 3 x. So now this you can write as sine of minus, taking minus common inside the sign, pi by 2 plus sine inverse 6 root 3 x. And you know sine of minus theta is minus sine theta. So that now this sine minus I can take out here. You know, because you know sine of minus theta is minus sine theta, right? So 6x is equal to minus sine pi by 2 plus sine inverse. Let me give a curly bracket here. Okay, so 6x is equal to, now you see here you have a pi by 2. That means 1 into pi by 2, an odd multiple. The sign will obviously change to a cos. Okay, now in which quadrant is this in? This is in the second quadrant, right? And in the second quadrant, sign is positive. So cos will be positive. But because here you have a negative sign, this negative sign will put as it is. Okay, but sign here will be positive because this is an odd multiple. That is why I've changed to cos. And because 1 into pi by 2 plus something is in the second quadrant, cos is positive. This negative sign corresponds to this only. This negative sign is not because of sign is because the angle is negative. Okay, is this clear or not?
Yes, sir.
Okay, so this
Yes,
is
sir.
cos of sine inverse 6 root 3 x. Okay, so now what you do is obviously you change your this sine inverse to a cos inverse. It will help. This becomes 1 minus 6 root 3x whole square, isn't it? Remember, sine inverse x is equal to cos inverse root 1 minus x square, right? That is what I have used here. That means 6x is equal to, that means cos and cos inverse will nullify each other. You get minus root 1 minus 108x square. Okay, now you square both sides to get 36x square is equal to 1 minus 108x square. So now 36x square plus 108x square will give you a 144x square is equal to 1. And therefore x square you get as 1 by 144. That means x square you get as 1 by 12 square. That means x you are getting as plus or minus 1 by 12, right? If you take the square root. Right now the question is which value is acceptable. Okay, so what you do is you put x is equal to 1 by 12 in the given equation, and you put x is equal to minus 1 by 12 in the given equation. Put x is equal to 1 by 12 in the given equation. You see that what is the left hand side? Left hand side is sin inverse 6x plus sin inverse 6 root 3x. Put here x is equal to 1 by 12. You get sin inverse 6 by 12 plus sin inverse 6 root 3 by 12, which is equal to sin inverse half plus sin inverse. If you cancel this, from root 3 by 2. And how much is sin inverse half? Sin inverse half you know is pi by 6, right? Sin inverse root 3 by 2 is pi by 3, right? If you add these two, do you get minus pi by 2? Which is not equal to minus pi by 2, right? Isn't it? So this shows that x is equal to 1 by 12 does not satisfy the given equation, because right hand side of the given equation was minus pi by 2. Does not satisfy the given equation. Hence, you have x is equal to simply minus 1 by 12 is the required solution. Is this problem understood? Yes, I'll stop here. Tell me, is this problem understood?